Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about Network Tools project for the subject CNS3200, Computer Network and Communication. Our lecturer is Prof. MADYA Technologies Professional Dr. Abdullah bin Muhammad, and our class group number is 5. The group members is Nur Sabrina BALQIS binti KHAIRUL AZAHARY 224007, ASMA MAISARAH binti AHMAD SYABUDIN 223022, SYAZANA binti MUHAMMED KAMARUL 224075, NURULAIN NAJIHAH binti ABDULLAH 224626. For the introduction, this paper analyzes the output produced from three networking tools which are ping plotter, DNS query, and TCP view. Using ping plotter, we can test the average delay, minimum delay, latest delay, and packet loss rate of the websites. Meanwhile, using DNS query, we can test record type, host name, and IP address. And using TCP view, we can test communication protocol, local address, remote address of the websites. These are the websites that we have chosen for our networking tools. For ping plotter, we choose for local website, we choose Jakim Official Portal, and for international website, we choose KBS World Home. For DNS query, for local website, we choose Nexus, and for international website, we choose Amazon. And last, for TCP view, for local website, we choose Putra Blast UPN, and for international website, we choose BBC News.
I will now explain on ping plotter. Ping plotter is used to detect the percentage of packet losses and determine the IP address of a website. But what is ping? Ping is the user connection's reaction time, or how fast a user receives a response after delivering a request. Even if your ping is low, you may still be experiencing packet loss. Thus, even though data is sent and received rapidly by the target server, some data may not arrive in the correct time. Let's move on to the important terms to know while using ping plotter. The first one is hop. Each row is made up of a series of hops, which are discrete devices that pass data along as it travels to the final destination. The next one is packet loss. Packet loss is when a packet fails to complete its round trip journey. Last but not least is IP, or Internet Protocol, which is a unique address that identifies a device on the Internet or a local network. We ran local websites on Pinkplotter during daytime and nighttime. As you can see, this is the data we got for daytime. The local website we used on Pinkplotter is Jakim Official Portal website. The IP address is 103.233.160.3.1. The image below shows the packet loss is either 0.4% or 0.8%. These packet losses only occur at hop 5, 6, 7, and 10, 11. One of the factors of packet loss for this case is network congestion. Network congestion occurs when there is excessive data traffic on the network, leading to overloaded routers and switches, which can result in packet losses as these devices drop packets they cannot process in time. Packet loss reduces the efficiency and performance of network communication, causing delays and disruptions in data transmission. The percentage of packet loss is low, therefore user experience is smooth and the network performance is good. Moving on to nighttime, the image below shows no packet loss except for the last hop, which is 100% loss. However, this only means that the website is using endpoint configuration. The last hop in Pinkplotter shows 100% packet loss, typically indicates that the endpoint, such as a server or website, is configured to ignore or block ICMP echo requests, which are used by Pinkplotter to measure connectivity. This configuration prevents the endpoint from responding to ping requests, leading to the appearance of complete packet loss at that final hop. With no packet loss, the network performance is great and user experience runs smoothly. We also ran an international website on Pinkplotter. The website we used on Pinkplotter is KBS World Home website. The IP address is 334.727. The image below shows the packet loss is 14.8% on hop 11. Some of the factors are network congestion and international link. Like I mentioned earlier, network congestion causes heavy traffic which leads to packet losses. An international link causes packet loss due to the increased distance and complexity of the route, which can introduce latency, congestion, and potential disruptions along multiple network and segments and interconnections. That's all from me.
Today I will be talking about DNS query. DNS stands for Domain Name System, which is used to translate human readable host name into IP addresses. And DNS will show several IP addresses that will represent as an identical server so that they will move traffic from a failing server to a very live server or redundant server. And there are several types of DNS record types, which are A record or quadruple A record, NMA record, CNAME record, SOA record, NS record, MX, EXT, SRV, PTR, and SPF. Here are some of the important terms in DNS query. Uh, the first one is DNS name. DNS is a system for computers devices connected to the internet that resolve domain names to IP address. AVG stands for average ping time for a particular hop, which shows the average response time for the last X, which X stands for focus time, at any timeout or when the lost packet are not included in this value. And then cur or the current, which is the most recent ping results, shows individual sample time of the most recent sample included in the set. In this project, we use CMD to look for a DNS query. And here are some of the command lists to use for your CMD. First one is NS lookup, which is to show any domain name or IP addresses. And then NS lookup negative Q equals MX. MX equals to mail exchange, which to retrieve mail exchange record, and it shows the server of the domain and their priority. And as lookup, negative Q equals to CNAME. CNAME equals for canonical name for the domain, and it shows the true name and alias points. And NS lookup negative Q equals to SOA, which is SOA is start of authority, which provide administrative information about the domain, either in a primary name server or admin email or serial number. And tracert is for the trace route or the path data packet that take from source to the destination and display each hop and the round time, which is RTT, for 30 hop per domain. For the local website, which is on daytime, I choose the maxis.com.my using for the hotspot Putra. And this is the result as shown in the picture. And next slide, please. And on nighttime, it shows a different one than the one before. And for the DNS query analysis of both the local website on daytime and nighttime, shows that they share the same canonical name, which is the C name, which is KAJ9 and XO.impervadns and .net. And also they share the same mail addresses, which is the MX record and hostmaster.incapsula.com. And the same serial number is 3002. And the default of both of the local website daytime and nighttime is 600, which is 10 minutes. But however, the server and the address of both of the local website on nighttime and daytime is very different. This is the example output for the international website, which is the Amazon.com. DNS query analysis for the international website, they have this different canonical name, which is not one, but three canonical name or C name. And for the mail address or MX is hostmaster.akamai.com. And a serial number is only one. The default TTL is longer than the local one, which is 30 minutes. And the server is only one, which is shown before. and the same address. Okay, that's all for me. Thank you.
Okay. Lastly is TCP view. TCP view is a Windows network monitoring utility that shows a graphical representation of all currently active TCP and UDP endpoints on a system, including the local and remote addresses and state of TCP connections. TCP view designed to send packets across the internet and ensure the successful delivery of data and messages over networks. TCP view provides a more informative and conveniently presented subset of the nested program that ships with Windows. So what are the difference between TCP and UDP? TCP endpoint is a unique identifier for each TCP connection and is the combination of a local address and a remote address. Meanwhile, UDP endpoint cannot be in a connection established state since UDP is connectionless. So this is an example for a TCP view interface. They are process name, process ID, protocol, state, local address, local port, remote address, remote port, create time, module name, send packets, receive packets, send bytes, and also receive bytes. So this is a table for all the result for the task. For the first column, I use a BBC Hope to test the connection. Next one is Putra Blast during the day. And the last column is Putra Blast during the night. So for all three connection, I use a process called Opera that will run on the computer system. Next is for BBC Home during the day and Putra Blast during the day. The process ID is 8920, while Putra Blast during the night is 13492. For these three processes, it used the TCP protocol, which is commonly used to communicate over the internet because TCP is a widely used transport protocol that ensures reliable, ordered, and error-checked transmission of data packets between devices across a network. For all three connection, it has a same status which is established, meaning that TCP connections are active and data is being transferred. So the local address for all three connection is 10.104.7.241, and based on the table that they are local port, remote address, and also remote port. Based on the analysis from the three connections, 7.241, since it has been consistently the same in local addresses, and all the local networks have an IP address of 10.104.xx, which means intranet resources, and all the public networks have an IP address of 74.125.68.188, which means external services. Based on the remote ports, port 8009 is used in all three connections to local network addresses 10.104.xx. This means that internal services are accessed even though we are browsing any website such as local or international. Port 443 is used for HTTPS connections, ensuring secure communications with external servers, and the difference in process ID reflects different instances of the browser sessions. For example, the time of day and specific browsing activity. Based on the process ID during the daytime, it is 8920, while during a nighttime, the process ID is 13492. So that's it for TCP view.
In conclusion, this project aimed to explore and analyze network information using tools such as ping plotter, DNS query, and TCP view. By utilizing these tools, this project successfully obtained network information for accessing international websites via our college network, which is hotspot at Putra 5G, and a local website that was tested during daytime and nighttime also via our college network. These tools showcased their individual functions and highlighted the importance of analyzing network performance, DNS resolution, connection monitoring, and path tracing in understanding and troubleshooting network connectivity. This is the list of references that we use for our slide, and that's all from us. Thank you.